Good morning, good afternoon, and good evening to all our viewers globally, and welcome to this webinar brought to you by IMarEST Houston, Gulf Coast branch. Our speaker for this webinar is Mr. Rajnish Kelkar. Mr. Rajnish is a Houston, Texas-based shipping and maritime expert. He has 33 years of international experience in management and operational roles in the oil, gas, and energy and marine industry. After completing his marine engineering training, Rajnish served on a large ocean-going vessel for 14 years with L&T Limited, Chevron Shipping Limited, and Tiki Shipping Limited, rising to the rank of a chief engineer. Mr. Rajnish is a chartered engineer and fellow of the IMarEST. For our global viewers, please kindly use the Slido link, which is available on the Eventbrite, to actually send questions to Mr. Rajnish at the end of this webinar. Also, the IMarEST branch also do offer a CBD to viewers attending this webinar at the end of it. So if you need the CBD, please kindly send an email request after this webinar to the event contact email provided to you on the invite. With that, I hand over to Mr. Rajnish. You have our full attention.
Okay, thanks, Demi. Hello, everybody. Again, good morning, good afternoon, and good evening, wherever you're joining us from. Thank you for joining us for this webinar today, and thanks to Demi for the introduction and to the Institute for organizing this event and for inviting me to speak on this topic. So I wish this was actually a live event in person, but unfortunately, we have to practice physical distancing. And today we are doing this remotely, but I hope you can hear and see me fine. Also hope and trust all of you and your families are safe during this pandemic and during these unusual times. I'm going to be talking about the process of development of LNG marine terminals, and it's mainly in the US. And the associated marine risks and issues from my work and some experience as a marine advisor and consultant in some of the US and Canada projects. I hope you find this interesting and useful and informative. Most of what I've presented in this presentation will be applicable to other types of terminals as well. So it's not specific only to LNG as such, although it is focused on that. So the agenda for today is basically looking at the following topics. I will show you a map of all the LNG export projects just for context. And then after that, we'll look broadly at the project management phases, different phases of that, and the opportunities for risk reduction for reducing overall project marine risks. We are focused on the marine aspect. We'll look broadly at the marine risk reduction as the project moves through its phases. And we'll specifically look at risk reduction in the permitting process, the application of codes and standards, the application of industry guidance and best practices, and by setting some additional company requirements over and above these codes and standards and the mandatory minimum requirements. And finally, we can see what we can do during operations by other measures. I admit this is a very large topic. I'm taking a bite of it in these 50 minutes or so that I have available today. So here's the landscape of US LNG export projects. Now this is from the FERC website. There's a lot of information there on the FERC site. You can go and see this and dig down in detail if you wish. This shows only the export projects, but our discussion today is for all terminals, right? Import as well. So this shows 22 of them. If you look at this list, it's 22 approved LNG export terminals. These have not yet been built. Additionally, there are more that are actually in operation right now, and 7 more that are proposed. So a very large number, of course, but you find that most of them are concentrated in the Gulf of Mexico area. There's a concentration there. There's only one on the West Coast, as you can see. And there's one in Canada right now being built. There's more in Canada they are permitted, but construction has not started. So the concentration is of these projects in the Gulf region, of course, is because of certain benefits of placing terminals there. Some of those are like a lot of gas is available, pipelines are already there. Permitting onshore and in the waterway is much easier, relatively, comparatively. But on the West Coast, you have the advantage of time to market, right? It's faster, easier, quicker to get to market. It's like twice the shipping cost if you send a cargo from Gulf of Mexico to China or Japan or the Far East, going via the Panama Canal. And it's 3 times if you go the other way through the Cape. So the shipping costs are immense, but there are other factors as well on the West Coast, which can prove a little bit challenging, but the opportunities are there. Right? So I just wanted to give you that context a little bit. Now here, I just want to talk a little bit about the project phases. All of these projects are like major projects. They go through 4 to 5 stages. The main phases are basically select, define, execute, and operate, which I've shown at the bottom of the axis. And I've overlaid the engineering activity on top of that, maybe not very elegantly, but it's there. It says pre-feed, feed, permitting, detailed engineering, and so on. Some of these things will happen in parallel, so it's not a sequential activity. It can happen in parallel as well. What we can see from this slide is that the greatest opportunity is in the early phases, when you're identifying and assessing the business opportunity, as well as doing site and concept selection, also layout optimization measures and things like that. As you go into the other phases, the kind of diminishing returns kick in, and you don't have so many opportunities to reduce risk to alarm. So you go from intolerable risk at the top here to alarm in the first couple of phases, from select and define, and then after that, it is basically putting in procedural measures and continuous improvement in place. And then once you get into the operate phase, you have other risks creeping in, modifications, change of personnel, creeping change, and asset aging and things like that. So basically what this means is that the site and concept selection is one of the most important factors. The select phase, right? Largest opportunity is available to reduce risk by choosing the best site and the best design possible, not only from risk, but also from the cost perspective. And choosing a site from the marine perspective, from the shipping and maritime perspective, although there are so many different criteria from the shipping and maritime perspective, there are a couple of things that I can say, very logical ones, like something like proximity to town, for example. It shouldn't be too close to a busy center or a town. It doesn't mean that you'll find a site that's always ideal, but that's one of the factors. Met-ocean conditions should be good. You need to be, we need to assess and see, because if the conditions are not good, you might need a breakwater. That can be expensive. You assess the channel approach. How deep is it? How wide is it? Is it too long? Because that increases the pilotage time. If it's not deep enough, you might need to dredge and things like that. Kind of traffic, one way, two way, because that increases risk. Also, the ability to get ships in and out quickly. Also, traffic density. What are the other vessels? Too many ferries going in and out and things like that. Busy port, recreational and commercial fishing and things like that. And also whether the port is developed enough. Does it have BTS, blah, 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 like anchorages and things like that. So there's a whole list of things. So if you get all those things right and put them in place, then in the rest of the project cycle, like in feed and in detailed engineering and all that, you can incorporate additional safety measures, and you can design your facility for basically sound asset integrity, as it's called. And of course, during the execute and operate phase, you operate safely and you maintain all your safety barriers. Again, just to bring the rest to alarm, right? So let's go further. So from the marine technical and operational risk management perspective, in this topic today of development of marine terminals, we can broadly say that risk reduction can occur in 4 to 5 key areas. So first of all, meeting risk and meeting all the regulations and getting the required permits. That itself is a risk mitigation activity. That's the minimum thing you need to do. Meeting codes and standards, you need to do that. Obviously, adopting industry guidelines and best practices. These are additional things that you can definitely do, to add measures in place. With some of these are also needed for permits. Company requirements are additional over and above these minimum requirements, and then of course operational measures and others. So now let us look at each of these, and I'd like to take the first two that we listed in the previous slide together. So I've listed a few main regulations and permits and codes and standards that need to be in place in the first instance to obtain the required approvals and permits. Now, this is for marine scope only, and this is not all inclusive. So let's see what's there. So the applicable international and national, state, and local legislation, you obviously got to meet that. You got to meet you got to get all the federal and state permits. You need to obtain them through the proper regulatory process. The NEPA 59A is basically the National Fire Protection Association standard. It is the standard for production, storage, and handling of liquefied natural gases. It has some key requirements that need to be met with. One of the key processes in all this from maritime is the US Coast Guard's waterway suitability assessment. We'll talk about that a little more in detail in the subsequent slides. Also BS 6349, that's the British standard, maritime works and structures. It comes in 8 parts. Not all parts are relevant. It depends on the concept that you've selected, the scope that you have, and things like that. There are US and European standards as well. Those alternatives are possible. This is not a mandatory thing, right? But it's definitely a good idea to use that as your basis for developing your project engineering design and scope. And also in operations, there's the IMO and the IGC code. IMO is the International Maritime Organization, IGC is the International Gas Code. We need to meet those for vessels which are in operation. So going to the next slide. So let's look a little bit deeper into the federal permitting process. And I've not touched the state process here because that's going to vary state by state. And also we don't have the time. But this process is like, it takes care of a lot of things are federally regulated, so it makes sense. It's very important. So FERC and the US Coast Guard are the two main bodies in here. This is specific to the US, but you'll have similar things, similar regimes in other parts of the world as well. So let's talk a little bit about the FERC regulations. FERC stands for Federal Energy Regulatory Commission in the US, and FERC's approval is needed to site and construct, operate, and place a facility or a terminal in the US. And it's required under the Natural Gas Act, Section 3 of the Natural Gas Act. So that's it's an independent body. They have the authority over this. Similarly, in Canada, there is, at least on the West Coast, there's the BC Oil and Gas Commission. So they are similar body to FERC. In the US, the FERC is the lead agency under what is called as the NEPA, National Environmental Policy Act, which requires them to follow a structured process for reviewing applications and permits, giving permits to facilities. And the other agencies that you can see here, FERC is right in the middle here in the screen. And the other agencies all around, you can see, are what are called as the supporting agencies or cooperating agencies. So there's Department of Energy, Department of Transport, Army Corps of Engineers, EPA, Environmental Protection Agency, Department of Homeland Security, and for specifically for Marine, the US Coast Guard. There's Fish and Wildlife, and there's even the Federal Aviation Administration. So they are listed there. The agency that you have deal with the most is the Coast Guard, but you have interfaces with the others as well from the marine perspective. So the reason why FERC actually regulates is because they need to weigh the benefits against the impacts, right? The needs and benefits. So it's a process which they follow and which is called as the environmental review process. The FERC review actually it consists of 13 reports that the applicant needs to submit, pretty detailed. All of these reports are actually for the projects that have been permitted now are available online. You can go and read them. They're public information. The process, it's extensive analysis and work, and it could be applications could be as much as 30,000 pages, thick. The process can take a year or more, and it goes through various phases where you need to hold stakeholder engagement, open houses. In this interim period, there are appeals and protests and public comments and additional questions that come through. But the result is that once it goes through the process, you basically get what is called as the FERC develops an environmental impact statement. It's in draft phase first, and then after the mandatory public comment period, it goes into the final environmental impact statement. And then FERC reviews that, the FERC commission, and then basically gives the order saying yes or no. So that's the process. Marine is spread into all these 13 reports in different places, and there's extensive involvement from the Marine team as well. And as I said, FERC weighs the needs against the impacts, needs, and benefits. So the needs may be things like economic growth and development, creating jobs, building infrastructure, growing on natural exports and things like that, tax revenues that come in, jobs that get created, community development and things like that, and meeting global demand for clean energy. So the FERC looks at those benefits, but weighs them against the impacts which are there, we must admit. There's impacts to air, soil, water, vegetation, there's noise, even aesthetics, safety, security, cultural resources, all these things. So they look at all that and then make a balanced judgment and a view on that. So one of the, from the marine perspective, the US Coast Guard the project is engaged very deeply with the US Coast Guard. It's the most relevant and important agency for marine issues because the Coast Guard regulates all maritime traffic in US waters and sets all the policy, safety, security, and operational requirements. The USCG's regulations require that the applicant completes and submits a waterway suitability assessment. This is it spreads across the span of the entire project, select, define, execute, and operate phases, and is also a key part of the permitting process. So as I said, the Coast Guard is one of the cooperating agencies with FERC. So the FERC looks to the Coast Guard to say, has the applicant met all your requirements in terms of safety, security, and operational things that they need to put in place, measures they need to put in place. It's a parallel process to FERC filing, and the guidance is given in NAVIC 01/2011, which is basically the vessel navigation vessel and inspection circular. Coast Guard has published that. All the guidance is actually in there, and it's very useful. You should take a look at that. The WSA is mandatory. A similar process exists in Canada. It's called the TERMPOL, Technical Review Process of Marine Terminal Systems and Transshipments. I think that's what it's called. TERMPOL is not mandatory, but it's strongly suggested that you do one because it's similar to this. I think the WSA is a little bit more stringent and more robust and rigorous. That's my view. So it's an assessment of the waterway, and Coast Guard is basically a collaborative agency. They try and include all the industry experts. They want the applicant, the project actually to work with all the local stakeholders, Area Maritime Committee, Safety Committee, and the Harbor Safety Committee. And the Coast Guard actually then validates all this and sees how you're doing and whether they feel comfortable that you have the capability to manage the risks of bringing vessels in and out of a US port. So one of the main parts of the WSA is the WSA risk assessment. Now this is classified as sensitive security information, or you can classify it as protected critical industry infrastructure information, which prevents it from being open to public sharing and dissemination. It's shared on need-to-know basis under a non-disclosure agreement under the Department of Homeland Security. So it's controlled information. It's all geared towards risk reduction in bringing LNG vessels in and out of the US ports, right? And includes navigational, operational, security risks in transit, including some possible intentional acts to damage the LNG carrier or facility. So it's a very important piece of work. Output from this is that you need to ensure that you have response plans, facility security plans, and transit management plans, which need to be developed along the permitting process, but need to be in place before start of operations. In fact, even before you start construction. Like for example, during construction, you might need a special security plan for module transportations and things like that. So very important piece of work. So a subset of the WSA risk assessment, I just want to talk about the security risk assessment part of it, because it connects to a few other things that we'll be talking further down in the next few slides. This too is a sensitive security information, or PCII, protected critical infrastructure information, and it evaluates security risks, right? Now, for a general risk assessment, we look at risk as a function of likelihood and consequences. But in security, you need to additionally look at two other dimensions of threat and vulnerability. So the threat is basically nothing but a function of who the adversary is, who's trying to cause harm. It could be a domestic or international terrorist. It could be an activist, protester. It could be even an employee, sabotage and things like that. And you need to also then think about how would they intend to carry out such an attack? What are the means that they would do it? Could it be a cyber attack, physical attack? And in that case, how would you do that? What is their motivation and capability to do something like this against a vessel, or to damage a vessel or a facility? Vulnerability is a function of the weakness and the sensitivity of the target that can be exploited by an individual who has the motivation and the intent to create damage, right? And consequences are obviously to adverse impacts to people and the environment, local community, and to the nation, in fact. So those are some critical things that are part of the security risk assessment. So this assessment has to be during construction, before construction, during construction, and during terminal operations as well. You need to continuously do this, have a security plan. But the WSA kind of stops once the facility is constructed, and all the things that it needs to develop or should have in place, which are being done through the permitting process, turn into actual operational plans. So based on your security risks, you might put in mitigation measures like surveillance, additional law enforcement, maybe escorting the vessels in and out of the terminal, and public notification systems, things like that. I mean, there's a huge list. Not everything can be touched upon here today, but these are some of the key things that might need to be put in place to bring the risks down. Okay, so also one of the actions from this security assessment is for the Coast Guard to establish a transit moving security zone around the vessel. Now this ranges from 500 meters to 2 miles. And the reason why it has a range is because it depends on the security and the threat and vulnerability assessment that's been done. It depends on whether the location, the terminal is in a very high visible and important location, whether it's a politically and commercially sensitive target area. It's the risk high because it's a very busy waterway, is a very populated region. Like for example, Cove Point in Maryland, and District in Massachusetts, they have security zones which are on the higher end of the limit. If it's kind of a little bit of isolated location, not that highly developed, which would be actually preferred, then it could be as low as 500 yards, right? It's not an exclusion zone. People make it out to be an exclusion zone. There's a lot of pushback from stakeholders like recreational and fishing and crabbing community, who believe that it's going to hinder their ability to go about their activities in port. So you have to do a lot of stakeholder engagement to ensure that they understand that that's not the case. It is for security. Coast Guard just enforces it if they need to, if they believe that there's a risk for LNG vessel in that area, they can enforce, they can ask a boat to leave that area, or they can go and inspect and it's things like that, right? It's just a very strong safety measure. I'm sure other countries might have something similar, if not the same. So, and again, it depends on what their risk profile is and what their risk appetite is as well. So now let's look at the zones of concern. Basically, we looked at the security zones, and we said that there's a chance of a vessel having being attacked possibly. There's also a chance of possible grounding. You can have vessel collisions that can happen too. Those are certain risks. They could be intentional or accidental discharge, right, of LNG. And once there's a large spill, a large quantity of LNG spilled on the water, of course, there's going to be a huge gas cloud, and then there could be potentially a large pool fire. So because of that risk, US Congress actually asked Sandia National Laboratories, which is located in Albuquerque, New Mexico, to study the impacts of these large pool fires. They did two reports. The first one was in 2004 for smaller vessels up to 150,000 cubics, and the 2008 report was for larger vessels up to about 265,000 cubic vessels, which is the QMAX vessels, right? So their study actually defines 3 concentric zones of concern based on the thermal hazard, from a large pool fire. And they have looked at accidental and intentional. They've looked at near shore and offshore as well. And they've given some broad guidelines. And they've said that if you want to kind of analyze this a little bit more, then their guidance is to do computational fluid dynamics, CFD modeling, so that you can improve very specific, improve the analysis for very site-specific hazards and put some additional measures and mitigations in place. So what are the mitigations? Now, on the right-hand side, I have a graph that shows basically this zone from start of the entrance of the channel to all the way to the LNG terminal site. It ranges from 0 to 500 meters for zone 1. And this is the zone within which the thermal hazard is the highest. It drops to about 37.5 kilowatts per meter square at the periphery, I think, so that within that zone. So this has higher impact on people and property. So some mitigations are necessary. Zone 2 and Zone 3 are decreasing levels of impact. In fact, in the lowest zone, I believe it's the thermal impacts are like 5 kilowatts per meter square, which if you shelter in place, then that is adequate. If you have some barrier, if you're not exposed directly, then you should be okay. But for the other, Zone 1 is a zone of concern, definitely needs some mitigation measures. And some of those strategies you can employ there are what we talked about as part of the safety and security zone assessment. Vessel security zones need to be in place. You need to manage the traffic in that area to avoid collisions. So having a BTS vessel traffic system is a good idea. Ensure that you have emergency response in place, capability for firefighting, with tugs, like on the tugs, have ability for salvage and response. We should have community warning systems and procedures, and also have educational programs for increasing community awareness of what happens in case if there's a large release. And of course, gas cloud dispersions, modeling studies and things like that. You can use CFD for that to understand specific hazards. So now we already looked at the marine risks with regulations, codes, and standards. And we also looked more closely at the federal permitting process and the marine risks addressed by the Coast Guard, WSA process, Sandia zones, and things like that. Now let's look at what the industry guidance and best practice has for us. So I've just picked 3 main ones. There's SIGTO, OCIMF, and Aang. There are others, but I've not listed all of them in the interest of time. SICTO is the Society of International Gas Tankers and Terminal Operators. Their recommendations are not mandatory, but are extremely important and relevant for risk reduction. OCIMF is Oil Companies International Marine Forum. They also publish the ISGOT, which is the International Safety Guide for tankers and terminals. They also publish moving equipment guidelines. The fourth edition is the latest one, I believe. So MEG, that's called MEG, moving equipment guidelines. And PANG stands for Permanent International Association of Navigational Congress, but I think it's been renamed now to the International Navigation Association. So these three bodies are extremely relevant for marine risk assessment and reduction. So let's look at SICTO, because SICTO is the most relevant and has published a lot of material on this for operations as well as for site selection and design. This paper in particular, the SICTO information paper number 14, is extremely critical. The central theme of this, just as it says, site selection and design, is basically selecting the appropriate site, which is what we talked about in our first slide, if you remember, the risk reduction in the early phases. So the central theme of this paper is basically to prevent a large energy release, which can happen through a couple of ways, and two major ways which you definitely want to avoid is damage to a hard arm or a rupture of the cargo containment system. These two things we just definitely have to absolutely avoid, right? So there's a lot of emphasis on risk reduction in the early stages in their recommendation for selecting the port and terminal location. They admit that, and we all know that, you can put risk reduction later on as well with operational procedures and other measures. But we have to remember that measures such as navigation, ship maneuvering, and other procedures are less secure and reliable because there's a possibility of human error, right? So it's extremely critical to get as much of it as possible within the design phase of it, because later on human error can creep in and you can still have an incident with everything still in place. So the recommendations that they make is for ideal conditions. Site specifically, you might need to actually adjust them a little bit. So these are not absolute values. So there were two, I've kind of taken this paper and summarized it in two main categories: the port design category and the jetty and berth design areas. So for port design, they say that the basic thing is the location should be remote from populations with least collision of risks and impacts. Main thing is it shouldn't be on a channel, curve, or a bend or a turn, because that's the area where the vessel is exposed. If it's LNG carriers alongside, it's exposed. Another vessel can lose power, steering, or whatever, or even intentional, and can bang into the LNG carrier straight at full speed, which can cause a damage to the containment. There have been LNG carriers collisions in the past, but never has the containment been breached. So LNG industry is pretty safe, but it is safe because of it following all these recommendations and taking all these measures, which we need to continue to do so. So a few of the recommendations are listed there. Approach channel should be 5 times the beam. Tug power should be sufficient for basically overcoming the maximum wind on the largest ship. There should be port limits set in, like at what maximum wind speed and wave height and current kind of vessel come in and out, things like that. Speed limits in the port for a vessel, so that kind of reduces the chance of collision and grounding. Traffic control, VTS, traffic separation schemes, things like that, very important to ensure that it prevents conflict situations or possibilities of collision. Turning circles, they've said, should be twice the overall length of the vessel, but of course depending on the current and some of the simulations as well. For the jetty, the main thing is that the terminal needs to have total control on and be able to exclude all the ignition sources possible. Mooring layout has to be well designed to hold the vessel strong enough in all weather conditions. Quick release hooks are optional. We'll talk about those a little later. It's kind of easy to release and reduces a lot of risk in operations. Emergency release system is there to ensure that the vessel can actually break away from the shoreside hard arm, so that prevents that big rupture and discharge of LNG spill. PERCs are part of this emergency release system. It's basically the dry brake release in case if the vessel drifts or something happens, mooring breaks, and the vessel kind of releases from the terminal, then there's very little spill of LNG. It's up to like 2 liters or so. Terminal security ensures that people can't get in without access control unauthorized, so we prevent the security incidents from that respect. And at both operational limits also need to be set. Just make sure that there's a procedure that people actually follow it. There's no gray area, and you will disconnect when weather or waves or wind or whatever reaches a certain limiting factor value. Now going on to PIANC recommendations. It's again, PIANC is the Permanent International Association of Navigation Congress. It's a very old and established technical institute since 1885 actually, and provides a lot of guidance and advice for marine infrastructure on development of ports, harbors, marinas, waterways, and things like that. PIANC has numerous commissions and working groups, and a couple of them, which are the most important ones, are the Maritime Navigation Commission and the Environmental Commission. MARCOM actually has developed quite a few relevant ones for our topic today. I just want to name a few. There's the one on ports being developed on greenfield and brownfield sites. It's called the Guidelines for Site Selection and Master Planning. There's one called the Master Plans for the Development of Existing and New Ports. There's one on Design of Harbor Approach Channels, underkeel clearance for ships, for example. There's another one called the Berthing Operations at Oil and Gas Terminals, Ship Maneuvering and Simulation Models, Tsunami Issues and Climate Change, and Protecting of Berthing Structures and things like that. So there's a lot of information which definitely should be referred to. You should have membership to this through your company account, or maybe you can join as a member yourself. So here I've just listed a few PIANC recommendations. They are very extensive. It's difficult to list everything. I just picked a few that I thought would be of interest. Some are similar to SIGTO's, but there are a few differences. Like, for example, PIANC says that the maneuvering basin should be minimum 1.4 to 3 times the longest ship. Okay? But of course, the design then depends on the port environmental conditions and the simulations and maneuvering studies that you do. PIANC says channel width should be 4 to 5 times the vessel beam, and that's for one-way traffic. If it's two-way, then it should be 9 to 10 times the vessel beam for two-way traffic. The channel depth and underkeel clearance 2 feet, 2 feet at berth, and 10% in the channel of the draft of the vessel. So these are minimum values. Right? And then the both approach speed, I think they've specified 122 millimeters per second, and also the maximum hull design loading. So there are some values which they're given in the studies. Safety distances between berths for different berthing configuration and things like that. So a lot of relevant information. So in most of the projects I've been involved with, we've done full mission ship simulators. This is actually a must. You may need to do many simulations. This is similar to aviation, simulators in the aviation industry. The simulations that we did were at CMA, California Maritime Academy in Vallejo, California. There is also the MITAGS, which is Maritime Institute of Technical and Graduate Studies in Maryland. They have the PMI, Pacific Maritime Institute. There's MSI, Maritime Simulation Institute at Newport. In Europe, there's Force Technology in Denmark. So there's quite a few you can choose from. All the data, hindcast data from the current and environmental conditions is input into the model. Bathymetry information is put in. You can simulate, for example, as is condition of the channel, and also if you're going to dredge and expand the channel, then you can do both to see where you need to do what exactly to make the transit of the vessels in and out very efficient and safe. You can do multiple. You can use the one main simulator, and you can use 2 or 3 different tugs and work as a team, tugs and ships together in real time with the real-time communications. And you can also test out new technology, things like differential GPS, portable power pilot units, and also add additional ATOMs of, identify the needs where you need aids to navigation, additionally, buoys and other markers that may be necessary, plus train your ship's crews before they actually bring the vessel in. So a lot of good risk mitigation measures there. So some of the simulation parameters that we used, you have to decide, excuse me, how many pilots will you have? So we had used 2. It depends on the length of the pilotage and things like that. Generally, for LNG vessels, you should have 2 pilots minimum, number of tractor tugs, and whether these tugs would be, tethered in active escort or just active mode, or would it be just escorting, and where would they actually tether, and so on. You can engage involve your ship owner and operators also into the simulation, bring them in, let them see it. You can bring in regulators as well, so they have the comfort. They actually want to see how you're doing the simulations and what the risk is, which is the US Coast Guard wants to see that. You can bring in customers and other stakeholders as observers as well. Do a lot of tests in terms of inbound, outbound, loaded and ballast passages. Day and night also, you can simulate failures, things like engine failure, steering, breakage, mooring, disabled tugs, and so on. And you can use, as I said, technology for DGPS and portable pilot units as well. So we were on this slide here. I think I clicked to the wrong place. Okay. So simulation will reveal a few other challenges and channel risks. For example, you might find that it's not wide enough or deep enough, or may have some sharp turns. So the selected channel may not be ideal from all perspectives, right? You might need to, may not be deep enough, wide enough, tidally restricted. There's also increasing trend of vessels. They're just getting larger and larger. Ports are not becoming larger. There's a lot of cost in dredging. So, the impact is that, maybe you may find that you are unable to bring in ships, or the margins of safety are reducing, that there's delays and things like that. So there are a lot of advantages. You can overcome all of these issues by dredging and widening and improve safety. But there are a lot of operational challenges to dredging as well. Something I just wanted to kind of touch upon on this slide. I just have one slide on dredging. So the operational challenges could be like mobilizing and demobilizing. There's a time and cost to that, right? There's also an issue with sometimes in-water work windows. You cannot dredge throughout the year in some areas. Maybe some places it's possible. But for example, on the West Coast, it's October to Feb on the West Coast. There's an impact to the benthic species and fish habitats. In some areas, for example, on the West Coast, there's the eelgrass, which is salmon habitat sensitive area. So you need to think about that, get appropriate permits. In the US, it's the Army Corps of Engineers that you need to work with pretty closely. And then dredging also has a few navigational impacts. You have issues with vessels being able to come in and out and things like that. And then the dredge spoils, the dredge material disposal. You need a plan for that. You need to consider how you're going to be dredging, clamshell or hydraulic. But there are advantages to both of them, pros and cons. Disposal, whether you're going to dispose it upland or onshore, offshore, and how do you stabilize the slopes of that if you do it on shore, and then issues with turbidity and things like that. There's if you're dredging, there's a chance of increase in sediment and turbidity in the water. Another big problem is that the material may be actually contaminated, in which case it's a big problem. And then so you need to test that before you actually dredge. And there may be, there could be even submerged wreckage in some area, and how do you deal with that? So there are lots of questions. In terms of disposal of the sludge spoils, you need to dredge spoils. You need to actually think about whether you want to put it on barges and take it off, or you want to put a slurry pipe and discharge it to where you want to put it. If it's a pipe, then does it go alongside the Federal Navigation Channel, or is it submerged and go across onto the other side? In which case, it has to be below the actual controlled depth of the channel, the official depth, and then it has to be marked. You got to consult the Army Corps and the US Coast Guard in doing all of these things. And then there's maintenance, dredging, and things like that, which you think about going forward. So a lot of things in dredging. It's a huge area which needs to be probably explored separately at some other time. Right? So now we just looked at marine risks with industry guidance and best practices. Now let's look at managing marine risks with company standards and policies. Now, when I say company standards and philosophies, I mean there's quite a few of them. I've just listed here the marine philosophy. There are many others, and I will not go into those. And all of those are actually, they capture all the requirements which are over and above codes and standards, and they are input into the pre-feed, feed, and detailed design. They basically capture the essence of the philosophies, that capture the essence of your design concept, and feed into the basis of design, detailed engineering, and design of the facility. And the marine philosophy is basically used through all the phases. It starts from identification and of the opportunity, right, all the way up to the construction and operation of the facility. So it's a very important document for project development. So let's look at some of the studies that are required as part of the marine philosophy. And again, this is not an all-inclusive list. I've just included a few. There's the navigation feasibility study, which ensures or checks to ensure that the vessel can come in and out pretty safely. Storage and logistics study, which looks at all the storage availability in your tanks, minimum capacity of the tanks, and whether you have tank toppages, tank tops, whether you will have a liquefaction output that can be sustained, whether you have number of ships that are coming in and actually leaving. It's actually a Monte Carlo simulation, which looks at all the variations and limiting factors and delays due to met ocean conditions, weather conditions, tank sizes, operational limits, and other outages. You can put in all the old met information into this and run the simulation. It tells you what size the fleet should be, and there's all kinds of other studies that need to be done. I think in interest of time, I'll kind of skip speaking about those, and we'll go to the next slide. So let's talk a little bit about certain other things that, other opportunities that are there in the project development phases and for the project to add to reduce risk. And there are two optional features, actually. Not all terminals may have them. So that's the FERC and the quick connect and disconnect thing. Marine loading arms, basically, they can be equipped with this FERC release system, and the connection to the vessel could be a QC-DC coupling. So the marine loading arms are required for discharge, loading and discharge of cargo, critical ship-shore interface equipment. It's important because that's the place where the containment is actually broken twice in every ship's visit, first during connection and then during the disconnection. The marine loading arms, or MLAs as they are called, they are articulated with the swivel joints. So they've got 6 degrees of freedom so that the vessel and the loading arm can move in a certain defined or designed movement envelope. So on one side is the presentation plant, as you can see on this on the picture on the left-hand side, and on the other side is a counterweight. Counterweight balances the arm, ensures that it kind of stays stable and is easy to connect and disconnect. And also in the case of emergency release, pulls the arm back towards the berth. On each arm, there are actually generally for larger terminals, there are 4 arms, 3 for cargo, 1 for vapor. Each arm is isolated by a double block and bleed ESD valve on both sides. I think you can see that in the screen here. There's the ESD on ship, and there's the ESD valves on shore. And these have, you can install basically PERCs on not the ESD, but on the marine loading arm, which you can see here, and the inset and the detail of that is shown here. So the emergency release system is part of the ESD system. So basically, the ESD sequence is the way it works is if there's excessive movement of the vessel, then ESD1 is triggered. ESD1 basically just shuts down the cargo and closes these ESD valves, and then within 30 seconds, the ship is isolated, transfer stops, cargo transfer will stop. ESD2 is actually a complete disconnection when the PERC ball valves, because there are ball valves at the either end of the PERC. There's one here and there's one here. So these ball valves will close within 5 seconds. There is a audible and visual alarm, and after the valve's positive closing is confirmed, the PERC will release. And it's called a dry release coupling because not more than 2 liters of LNG is usually spilled, which actually flashes off. It doesn't spill, so that's a good thing. It just flashes, but that's a gas cloud, and that's again something that you want to absolutely avoid, and happens only in an emergency. The QC-DC is actually optional as well. In most instances, it could be just a basic flange connection. It can be upgraded to a quick connect disconnect, which makes it easy to connect. Because when a vessel is in motion and if there's a lot of heave and surge, you don't want to be there trying to take boats out or put them. It's just dangerous. The coupling has got a hydraulic operation, and that hydraulic operation is an independent thing, so you can actually you can release that pretty easily. It's just a risk reduction measure for safety of personnel, but I think it's extremely important and should be part of the design. So we talk about the ESD. Now the ESD is actually activated both simultaneously ashore as well as on the ship through a ship-shore communication link. It's called the SSL. So it just prevents any delays, communication lapses, things like that, which can be issues in resulting in an incident, and that must be avoided. So it basically interlinks ship to shore. It's a fiber optic cable. Pneumatic is used as a backup. If it's fiber optic, then you can transmit not just ESD signals, but also voice data and other. Now, mooring and berthing is another very critical operation, and it definitely must not be underestimated. There have been lots of incidents due to errors caused, which can result in berth fender or hull damage. A few things that the project can do and should do, strongly recommended, is to follow all the OCIMF and MEG mooring equipment guideline 4 recommendations. One of the things optional again is to install the docking aids display system, the mooring load monitoring system, and the quick release hook. So you can see the docking aid system here on the right. So that's basically a distance speed approach indicator. It uses laser to tell you and tell the master and the pilot real-time information on where the position of the vessel is relative to the berth and the approach speed. It can have alarms and things like that. Usually displayed on the berth, but the pilot can have a portable unit as well, if that's possible. And then the other thing is mooring load and tension monitoring system, which you can see on the left-hand side of your screen. And then there's the quick release hooks, which again are optional. It just, as I said, releases ropes instantaneously. Good mitigation to reduce potential for injury and move very quickly if and when necessary. So the other things you can do in design are basically install some kind of a real-time system like the NOAA port system. It's called the NOAA is the National Oceanographic and Atmospheric Administration in the US. Ports is Physical Oceanographic Real-Time System. So this system measures, collects, disseminates, and predicts all absolutely accurate real-time data, and it's for the US only. In Canada, they probably have other systems for doing that. In other parts of the world, there might be as well. If not, then it's a good thing to implement, improve safety and efficiency of maritime transport and commerce. In the US now, about I think 60 out of 175 large ports have this. So there's still scope for expanding that even in the US. It's usually a public-private partnership with NOAA to design, install, and maintain. You can have sensors like the acoustic Doppler current sensor, tide measuring sensor, met data collection, wave monitoring. Some of these buoys can also be installed on, may have to be installed on the Scripps oceanographic buoys and not Coast Guard buoys, but some of them could be installed on Coast Guard buoys. So lots of advantages, and one key advantage is, of course, minimizing impacts of grounding, even air gap, like if you're passing on the bridge, for example, as you can see in this image here. Also maximizing the cargo that you can lift. People try and keep margins up their sleeve because they're not sure exactly what the tide is, the depth is, salinity is, because the real-time data is different usually from, invariably, it's different from the measured, actual measured data. Predicted data is different. So almanac information is not that accurate. So if you can increase cargo carrying capacity draft by even 1 inch or a centimeter, that could mean a lot of extra cargo that can be lifted. Also useful for local emergency response and oil spill response monitoring people. So lots of advantages in the NOAA. Vessel traffic information system or traffic system is basically similar to air traffic control. There's like one individual has oversight of all the activities in the bay and can track that, can prevent deconflict the issue before you realize on the ship that you may be in conflict with another vessel and a collision situation may be occurring. So there's a benefit to this, not just to the project, but to other vessels in the area and also to the other stakeholders and users of the bay. So that has to be emphasized. But it's a good thing to install and something that you should. So some of the other measures that you can put in place, basically operational and other measures, would be having some sort of a safety management system. This is once you get into the actual operational phase. You need to develop this at the start and then build it along the way. Marine Terminal Management System, MTMSA, stands for Marine Terminal Management Self-Assessment, OCIMF's method of assessing yourself. And then, of course, following that up with external audits. You will need to develop a Terminal Marine Ops Manual, Board Ops Manual, operational procedures and emergency maintenance manuals and things like that. So all of these things need to be developed as the project progresses. And one of the most important things that you can do is ensure that you increase local engagement and content. For example, you can use local boats, mariners, and as contractors for other services during construction activity. You'll need the tug contract. Maybe those people can man the tugs, operate the tugs, other marine services as well. So there's a lots of opportunities to engage, and I think these are all good things to help bring the risk down. Pilots organization, you need to be committed to that, to develop it, training and hiring of people, working with the port authority, simulator training in advance so that all are prepared, participate in the Area Maritime Security Committee and Harbor Safety Committee, and of course, local spill response and with drills and exercises. And that's basically your emergency plans, transit management plan, which covers vessel coming in and out, facility emergency response plan, and the ship emergency response plan for during transit. So these are absolutely essential, have to be developed during the permitting phase, but then move over into the operational phase later. So we are at the end of our presentation. I'd just like to summarize here to say that we reviewed the various aspects of the development of marine LNG terminals in new or existing ports. We also saw that the greatest opportunity is in the early phases. And we looked at the process and reviewed the following means to reduce risk by meeting regulations and doing a very well-defined and robust permitting process, following all the relevant industry best practices and guidelines, implementing company requirements, philosophies, and so on, and adding risk reduction further into operations. So let me take you back to the original slide here. I just want to put this here to emphasize that risk reduction happens a lot initially in the select and define phase, but it doesn't mean that risk opportunities do not exist beyond that. They exist at the greater in the earlier life cycle, but exist throughout. So with that, thank you for listening, and I'll turn it over back to you for any questions.
Thank you, Rajnish, for the well presented webinar. We want to move now into the Q&A section. We do have some few questions from our viewers. The first question here is, can you share your thoughts on how to calculate exclusion zone? Are there any publications which provides guidance on that?
Exclusion zones. I think basically you need to review the sector information booklet. I think that's a pretty broad set of criteria, but sector definitely will have information on that. There's information on PANC as well. I don't remember the exact publication number. There's so many of them, but there's information on the safety zone between vessels at berths. And that's for different berthing arrangements. So yes, so there is industry guidance for that. Of course, it's always risk-based approach, right? You'll have to do your analysis, see what the potential is, whether you have control over all the ignition sources in that area. You might need to do some modeling as well, and that will give you a better handle on what that exclusion zone is. So, again, these industry guidance and best practices will give you certain recommendations, but it's always tempered with the fact that saying, look at the risk, analyze your risk tolerance, and bring it down to ALAR, which actually means as low as reasonably practical.
All right, thank you for that. Yeah, the next question is there any interest in constructing offshore loading and offloading terminals similar to Loop?
I think for LNG, I think that's kind of challenging. I think it depends on where your terminal is based. Again, site specific. It depends on the metocean conditions there, the depth, whether you need breakwater, and like offshore, you're talking about like FLNG terminal or a shore-based terminal with pier extending out. There are lots of options. It all needs to be studied. Again, it's site specific. I don't know of any proposals out there to put LNG facilities out offshore. For example, as you say, in the case of Loop, I'm not aware of that. But having said that, I may not have all the information. So anyway, so if I do hear of something, I'll let you know. But I've not heard of any such facility offshore, because the conditions are kind of severe, and I don't think you want to do LNG operations in an environment that is exposed.
All right, thank you. The next question. Can you define for the time measurement in average of developing the new ports according to the areas in accordance with the graph shown?
So you're looking at basically the timeline for port development. Is that if I can summarize the question, you're looking at the timeline basically, right? Yeah. So I think the timeline depends again on the permitting regime there and the place that you're going to put the terminal in, and permitting regime and the regulatory regime, right? How stringent it is. Like in the Gulf Coast, it's easier compared to on the West Coast. So again, in the rest of the world, it may be actually faster or it may be slower. I don't know. It depends. I haven't done any international projects as such. So I would say it depends on the regulatory regime. It depends on the you know, other factors of that location. But generally speaking, I think permitting should take you about a year or so. It depends. And a lot of activities can be done in parallel. You can do the select phase and the define phase and the execute phase. Some of the parts of those you can do and run in parallel. Aang has got a very good graphic in that. It's called development of ports, master planning. Look at that. There's a lot of information on that. They've shown all the, like, if it's a new port, what is the minimum, like, standard time that you would need. Again, it's not prescriptive. It will depend on your unique situation, but at least it tells you how much time you need to kind of put in and budget for each of those specific activities. So Aang is the place to go to. I think it's called Developing Ports in Brownfield and Greenfield Sites. I think that's the name of the publication. Refer to that. There's a lot of information in there. I mean, construction can take anywhere from 2.5, 3 years to, you know, in that time frame, right? So the whole project costing billions of dollars can be over, I would say 4 years, 3.5, 4 years minimum. That's what I would give for the whole thing, right from start to end. And that too, I think, is very optimistic.
All right, thank you. The next question. What mitigations measures are required to expose terminals? Which publications can you provide as guidance?
Exposed terminals. Okay. So first of all, again, depends which region you're talking about. Is this in the US or Europe, or in basically in other parts of the world? It'll depend. If it's exposed, then you obviously have to look at all the, as I said, the ocean conditions, the heave and swell and waves, and the potential for the loading arm envelope being exceeded. You also need to look at the structures a little bit, you know, what kind of impact it's going to have with the wave action and things like that. Aang is an excellent source. You know, just go into those. There's information on berths and terminals, master planning for berths and terminals as well. I would stick to OCIMF, Aang, which we talked about today, and SIGTO, which is the Society of International Gas Tankers and Terminal Operators. They do a lot of work in analyzing these risks, and they put a lot of mitigations. I mean, they suggest a lot of mitigations, and it's up to you to actually implement them. And I think they're all born out of industry experience, lessons learned, and sharing of learnings from incidents as well. After the incident occurs, a full incident investigation reveals certain things, root causes which need to be addressed. Some of those may be root causes in design, and those you might need to address as well. So being connected with these bodies, OCIMF, SIGTO, Aang, I think that's why I picked those three to put in there. It is extremely essential, and they'll have appropriate documentation. You can buy SIGTO's publications from Witherby Seamanship. It's in London. They publish all SIGTO publications, and you can have access to that for your company. And it's not expensive. It's a good thing to do.
All right. Thanks for that question. It appears that is the last questions we have right now for the webinar. So we're going to bring the webinar to an end. But before that, we want to announce our next coming webinar, which is entitled Engineering Solutions versus Administrative Controls in Fire Safety Systems. This webinar will be taking place on the 26th of May, 2020. We encourage all our viewers to sign up to this webinar and also avail themselves so they can actually benefit fully. We're also encouraging our viewers who have actually attended this webinar, if you desire, if you requested, to kindly send an email to the events contact email on the Eventbrite for them to request for their CBDs if you really do need one. So we thank you for attending this webinar. and also thank Rajnish for the time and effort put in developing this very resourceful material. Thank you all, and see you next week.
Thank you.
Thank you.
Thanks, everybody.